Read question number 4. Figure shows a small wheel fixed coaxially on a bigger one of double the radius. Okay, so we have the figure. Draw the figure. We have a figure, right? So we have a bigger wheel here, and right in the middle we have a smaller figure, smaller wheel, and then there is a mass, right? There is a mass from this guy as well, right? Right. This mass is A and this mass is B. And let us read the question. Figure shows a small wheel fixed coaxially on a bigger one of double the radius. So radius of bigger one is actually 2 times the radius of smaller one. Right. The system rotates about a common axis. So we have an axis like this, and there are 2 discs. One a small disc here, and on top of this another bigger one. Understand? And there are 2 masses suspended. Okay. The system rotates about a common axis. The strings supporting A and B do not slip on the wheels. The strings do not slip. And what happens if X and Y are distances traveled by A and B? X and Y are distances traveled by A and B. Then in the same time interval, then see, what is the distance traveled by A? Distance traveled by A. You know, let us imagine that the arc length here is arc length. If this angle is theta, how do you find arc length? Angle. You have learned this many times, no? Theta is equal to arc length divided by radius. Small class, lower class, you learned this. Angle subtended is equal to arc length by radius. Angle subtended here is equal to arc length divided by radius. Okay, so if I cross multiply, I get what? Arc length is equal to theta into radius. Okay, theta into radius. So this distance is actually what? This distance is actually theta times radius. Theta times radius. Okay, I'll write it bigger now. Right. Theta times radius. Okay. Now what happens when this rotates? What happens when the system rotates? The coil is unwinding. Am I correct? The coil is unwinding. And the coil is coming down. Sorry, the wire is coming down. When the wire comes down, the mass travels a distance. This is the new position of the mass. Okay. Right. What will be that distance? You know, if it turns through an angle theta, this distance traveled is same as the distance covered here. Let me repeat. When the coil, when the disc rotates, when the system rotates, the wire unwinds. So just imagine that the system is rotating through an angle theta. So where has this point gone now? Through a distance of theta. So the distance traveled by that point is theta r, which means the string has come down by theta r, or the distance traveled by it is theta r. So for the first one, how do I write? The distance can be written as theta times r. For the second one, how do I write? Distance is theta times 2r. Why 2r? They say that the second one is having double the radius of the first one in the question. Okay, but theta is the same because they are turning together. And if the first disk is rotating through theta, second disk is also rotating through the same angle. Okay. So if I divide, I get x by y is equal to theta into r by theta into 2r. Theta get cancelled. R gets gone on numerator and denominator. You cross multiply, y is equal to 2 times x. So the correct option is option C. Right.